the famous collapse of the wave function, the collapse of the quantum state. That is axiom 5. Because you might say, well, what if I do a measurement and get a result? What if I measure the same thing again? Do I get another probability again? That's not, the answer is, well, you should get the same result again. How is that ensured in quantum mechanics? And this is the final axiom 5. On getting the results, the measurement results, be very clear, use my very clear language here, measurement results, lambda A, the new quantum state is obtained by collapsing the old quantum state down to that eigenspace and normalizing back to 1. For a state vector, what this means is if it's a state vector, you're supposed to replace it with, you act with the projection on that state vector and divide by the norm of the new state vector. We replace the old state vector with a new one, a collapsed one. So for example, if that projector happens to be rank 1, if there's a unique eigenvector, and what this means is that your old state vector is replaced with the eigenvector. And this guarantees if you redo the exact same measurement right away before you allow any Schrodinger unitary evolution, with probability essentially 1, you get exactly the same answer. We lock in the answer. Those are the axioms. I've now given them to you. You now know all of quantum mechanics, all of it. It's now in your brains. You know it all. Okay, now you may have some questions. First question is, what the hell's going on? What about, like waves and stuff? Aren't there like waves flying around and double slit and there's like waves that go through the holes? And what about atoms? They can be like in 2 places at once, right? I mean, and chemistry, right? What do they always tell you about the atom in chemistry? If someone says, well, what are the electrons doing in an atom? What are they doing in an atom? What do people say?
Cloud, they always
say. It's a cloud, there's cloud. There's an electron cloud. It's like a cloud everywhere. Do you see any clouds here? What's the clouds?
Cats.
Cats. What about cats? See cats here? I see cats. Close. Cats, pretty close. There's cat. Cat.
We got a cat.
What about, you read popular books and stuff. There's like, the particle experiments, they have an electron flies by it and emits a photon and the photon's emitted. But where is, I don't see any paths of things and photons and electrons. I'm going to let you in on a secret. All that is just for color. How many of you ever seen the movie A Serious Man? Really? It was in the New York Times top 100 movies of the 21st century. Come on. Okay. You all have an assignment to do. You got to see A Serious Man.
Sorry, the analogy, I mean, in Newton's laws, there's no like Earth and Sun and Moon, right? So the fact that these objects do not appear in the theory explicitly does not mean that they are not applicable to.
Oh, excellent question. There are no planets in Newton's laws, are there? But there are some things in Newton's laws. Bodies. Newton's laws have bodies in them, bodies in space, in inertial reference frames, with inertial masses and forces acting on them. Those are all in Newton's laws. Now, what particular bodies are there? I don't know what particular bodies there are. It will depend on the system. But there are not even generic particles or cats or waves here. Like, they're generic bodies, and there's absolutely generic bodies moving in space in Newtonian mechanics with accelerations and velocities. There are not even generic bodies or things here.
But there's a system.
There is a system. Yes, there is a system. But what is that system?
It's just some map. It's some stuff doing some things.
The observables allow for whatever energy, position, things like that.
I noticed that you were literally waving your hand, sir.
I'm not a physicist, but they do allow. I mean,
so with this, people will say this, and I'll say, you notice you're literally waving your hands.
Okay. But
There's a reason for the term. People say it because they really do it.
So there are quantities being manipulated by this mathematics
Yes.
in a certain like fashion, very, I'm waving my hands again, but there's a parallel
I'm a New
between,
Yorker. I do that a lot. I'm very happy.
there's some sort of parallel between the way that quantities flow through this mathematics and the way that quantum stuff happens in reality.
What happens? Happens. I didn't use the word happens anywhere. Did anyone see me use the word happens? No. I didn't say the word happens. The only thing that happens here is that quantum states do this thing where they evolve in time unless they are measured, and then on measurement, they collapse and results show up on measuring devices. That's all that happens according to these axioms.